Thank you. All right, everybody, welcome to the Campus Research Computing Consortium system-facing call for September. And just a reminder, CARC, or Campus Research Computing Consortium, is an organization that advances the frontiers of research by improving the effectiveness of RCD professionals, including their career development and visibility, and their ability to deliver services and resources for researchers. And these are some of the tracks that we have in addition to this one: research facing, data facing, emerging centers, strategy, and policy facing. And we always welcome topics. I think, Brian, we probably need one or two additional steering committee members. So if you're interested in volunteer, if this is, an area of interest for you, we'd love to have you. Just reach out to one of the co-coordinators, which is Brian Haymore and Matthew Smith. So without further ado, we're going to be talking about storage planning and expansion today. And to sort of kick off the discussion, because we know that you all have your different problems, we get this presentation from Derek Haig from Penn State. And Derek is an HPC systems engineer with the Institute for Computational and Data Sciences at Penn State. He currently focuses on the automation of processes and workflows, and he's looking at, like I said, expanding their on-premise storage, but doing so in a fiscally responsible and computationally responsible manner. So without further ado, I will stop sharing my screen, Derek, and I'll let you take it away. Thank you very much for helping us out this month.
Yeah, thank you.
And while he's doing that, I should say, if you look in the chat, there'll be a link to the call doc for today. And please sign in, and also, give us suggestions for new topics, help us take notes, put any questions you have there or in the chat area, and we'll have people periodically stop Derek if there's some questions in the chat, and have them answer those at that time. So take it away, Derek.
Thank you. Yeah, so I'll just be giving a quick presentation of some of the storage analysis I did here at ICDS, and hopefully that can foster some interest and discussion amongst the group. Starting off with a bit of background information, our cluster, Cloud, currently has a storage solution of about 12.5 petabytes. It's split between users, home and work, and a PI only active and archive storage. These are backed up by service level agreements and have a quota that's specifically for a PI's usage only. Currently, the active and archive quota is total to about 10 petabytes. This is just the quota, not the actual utilization. Current utilization is more like 9 petabytes amongst all of the sources, so it's including the home and work and any other usage that is on that system. So among all that, it really begs the question of, do we need to buy more storage? If we do, when? And how can we back up that with data and have like a really thoughtful process for when do we need it? What other kind of growth trends are we looking at? And just stuff like that to make a better fiscal decision when it comes to increasing storage. So as part of this analysis, some of the data that I used was our SLA data, our service level agreement data. I would take the products and use the end and start date to kind of build a day-to-day point of how much is being used at a time. Corresponding with that, we have some time series data of the actual utilization on the system. That's stored in Grafana and some various other data sets throughout the system that I gathered using a collection of Bash and Python scripting. And once I'd had all that data, I would do some forecasting with it using the skTime Python library. So that's just kind of going over again the methodology for how I gathered the data. I had to do some cleaning of the data, any kind of cutting off and like the head and tails of the time set where there was basically no data, or any time in interspersed through the data set that was empty, I would interpolate the entry, since most of our storage growth trends are linear in a sense. You could just kind of take the two nearest points and assume the storage was somewhere between those. So part of how I was evaluating a good forecasting model, what I did is I took these data sets we previously mentioned, and I would split them into two parts. I'd have a training set and a test set. The model would be fit against the training set. And then I would have the model forecast based on that test set, on that training set, and comparing that prediction to the test set, I was able to get a mean absolute percentage error. You can see here in this table some of the different evaluations I did for different forecasting models with different sizes, the 30-day out, 90 days, 180, 360. I would average those, and I would use that to evaluate what I felt was the best performing forecasting model for our data sets. I did this for both our SLAs and the growth of our active storage. Just some of the results I had from the forecasting. So you can see here, this is a 1-year prediction of the growth of our SLAs. It's split into our archival and our active growth, and then a summation of the two. Based on the forecasting I have here, it seemed to be a approximately 3.6 PB increase in our SLA obligations. Now that isn't necessarily the increase in how much storage is used. Most PIs do not get anywhere near the actual full utilization of their storage. This would be just more how much are we promising to PIs in total, and it would correspond to like the quota size on the system. Now the actual active storage here, much more modest increase. It's kind of leveling off almost at the moment, or a much lower growth, almost a quarter of a PB over a year. You would notice that there's quite a steep increase through 2023 to just the beginning of 2024. A lot of that's because of a migration that we're doing between systems. So we're carrying over a lot of data from the previous system in a very rapid manner. So that actually did have some effects on the forecasting when I ran it a few months ago. A few months ago when I ran this model, it was projecting maybe a 1.5 to 2 PB increase over a year. It's since leveled off much more. I think that emphasizes the importance of running these kind of evaluations in a consistent and intermittent time span. So maybe every quarter, every few months, whatever makes sense for a workflow, just to try to catch these changes in growth and help you adjust your metrics as you move along. Similarly, I have some predictions for 3 years out. 3 years I picked because that's the projection. That's approximately the remainder of the life cycle for the system we're on. So I wanted to have an idea of like, do we seem like we need to expand the storage for the system, or does it make more sense to, does the storage capacity that we're at now seem good for the current lifespan of the system, and we can focus more on replacement system requirements. It would also, because we tend to merge storage from old systems to new systems as we migrate users. It helps kind of give us a baseline of expectation for future systems. Over here, you could see an increase of 10 PB over a 3-year period. That's between both the active and the archive SLAs. Again, this isn't necessarily a 10 PB increase of actual utilization, but of expected user needs or requests. Sorry, I'm looking at some of the questions that showed up. Is there a limitation imposed by the distributed storage system on the storage usage and more, say, as a percentage of actual capacity, such as to ensure timely automatic balancing of distributed storage targets?
Do you need Carl to clarify that question, Derek?
If I'm understanding, you're asking, do we do any kind of do we have any means of limiting how people utilize storage, or is it kind of just you can fill it up as you need to? Does that sound right?
Carl, are you able to unmute and ask that question?
Yes. Are you forced to say enforce purging of old data to keep the actual usage from getting anywhere near 100% capacity of the storage system? Does that make sense?
Yeah. So at the moment, I do not think we need to per se. As people's SLAs end and we either leave the university or finish their projects on the system and no longer actively utilize it, we do want to take that data off because it's just kind of using space without any need to be there. But we don't have any kind of automatic aging off or forcing of data deletion.
And that might,
sorry.
yeah, go ahead, Carl. Is that answer your question, or do you want to follow?
Yes, that's great. Thank you.
Okay. And then so Dave asks is how are you tracking storage fall off? And I think you sort of alluded to that just a minute ago about PIs leaving or their SLAs ending.
Yeah, I kind of touched on it. It doesn't have any immediate effect on the actual storage as it lives on our system. That is something that we definitely want to work on and improve. We do generally know when a PI leaves or their project ends because their SLA usually lapses, or they have some means of letting us know that they're leaving the university. So it's more of a case of us working out a process for how long we feel we are obligated to keep that data or remove that data as it is no longer actively supported by the PI's projects.
Great. Thanks. Thanks, Derek.
So then corresponding to this SLA prediction is the active storage. Again, you can see it's kind of, as it's appears to be leveling off in that first year, it shows similar decreased growth over a 3-year span. In this case, somewhere between a third and a single petabyte or PB of data. That, while it's not only active storage on our system, since active is the largest percentage and growth, I guess, vector for our storage, if it's only growing a PB over 3 years, I think that puts us safely under the target that the 12.5 petabyte that we have. So I guess I'll just go by conclusions since I'm kind of talking about them already. Our storage needs keep growing. Active looks to be leveling off. Archive, as active levels off, we do feel we have an increase. We'll have a percentage increase of archive just as a total of that usage. So like growth still seems to be pretty strong, but actual utilization is not necessarily meeting that growth. And we certainly seen, based on this forecasting, that our current capacity should be sufficient for definitely the next year, and it seems likely the next 3 years. But consistent reevaluation forecasting is important for keeping that accurate picture as you move along. What's true now in terms of how PIs are utilizing storage may not necessarily be true in, say, 6 months or a year. So it's important to keep reevaluating that. When you talk about SLAs, you're talking about provided capacity. So what about SLAs around throughput and latency? So part of our SLAs mainly just prescribe storage needs and compute needs. We do specify generally what the metrics or what the specs are for the compute and such like that, but we don't necessarily have PIs who are paying for specific levels of throughput or latency on the storage. So a question from Emery: how do we count for backups? Are backups included in the usage and therefore required to remain beneath the size of the SLA? Or is it possible for users to ultimately use above their SLA amount, including backups? So backups do take up some amount of the system's storage. It is not necessarily a one-to-one. I don't have the full picture on our backups, but I know they're stored in the same storage. So yeah, there is some growth. I think that's where let me kind of go to my last slide. There's some shortcomings, future actions, things that I think what I have here is like a good baseline to start, and I feel like there's a lot of room for expanding and getting a more holistic picture. Part of that is expanding my archive or my active forecasting to include pretty much any aspect of the storage growth. That'd be the archive, which we do have numbers for. We just don't have the time series incorporated in this forecasting at the moment. But I feel if you get to the point where your entire storage is in that forecast, it can account for any increased needs from backups. So, or even if we are expanded to other storage solutions that we have that we also want to be tracking.
Is this your last slide, Derek? I think it is.
Yeah, I think it is. Yeah. So just other things that I think can be improved. We can talk more about it with the whole group is different. What I picked as models don't necessarily need to be the best models. Maybe there's other aspects to explore, be it some kind of machine learning model or other forecasting libraries. And having it be more of a pipeline process so we could have it kind of be that help keep it that consistent and automated information source. So you can kind of pick any. So if you're like, I wonder what our storage growth looks like in the next few months, you don't have to go through this entire data scraping process and stuff. You can just have a place to look and you kind of have a forecast available right, easily. That's pretty much all I have. So I'll scroll and look at some of these pictures.
So Victor asked as a follow-up, is he was asking about throughput, or latency and throughput demand because of some of his users that are using it to capture data from an instrument and therefore need some level of capacity or throughput and latency in terms of the speed that the data can come off the instrument.
Right. We have some users like that. They the specific group escaped my mind at the moment, but they have like some telescope or imaging instrument that provides a lot of data at once that is kind of in the moment data that can be very large in quantity and throughput. I think in that case, we mainly just tried to maintain a relationship with that group and have an understanding of their needs when it comes to our design of systems. There's some ways around it, like providing specialized entry points for the user so that they're not getting contention on networking throughput. Does that answer that question?
Yeah, and there are some.
I think ours is also cryo-EM.
Yeah. Well, I think with the cryo EM and a couple of the imaging devices, they sort of buffer it locally, and then so they have disk space locally that it can accommodate, 2 or 3 runs, and then they load it through some of those specialized entry points that you spoke about to your storage. I think that's the way it works. And similarly for LIGO, the LIGO real-time system, they sort of buffer that onto another system and then load it up to where it's computed on.
Yeah, LIGO has some storage, I think in the same space for us as well. And I think like you said, I believe the cryo-EM people on Penn State campus, they have like a local Linux machine that does kind of a buffering, and then they offload it onto our system.
Right.
That is in fact exactly what happens with us as well, where we have a local buffer, but the complaint has been as we're buffering off of the capture machine onto the Linux machine that then puts it onto our storage, the researcher has a very high set of demands in terms of making sure it makes it off of the entry point buffering and into our actual storage.
Gotcha. So the question is about why did you decide on on-prem storage versus contrast that to storage in the cloud?
I think a lot of it just came down to the cost benefit analysis for the researchers. Some users are operating in enough data individually that just the ingress or egress would be prohibitive, and we just felt we're operating at a ordinate scale that, so we're at like about 9 petabytes, that we just felt the cost of having that kind of storage footprint in the cloud would be prohibitive compared to an on-prem solution.
And Derek, I don't think you did this already, but could you kind of briefly describe what your on-premise solution looks like for the Rourke Lab cluster?
Sure. So we have 2 storage appliances. One is a vast storage solution. I believe it can do multiple things, but mainly we use it as like an NFS share across the system. That I don't need to get too into the details of how they do it. I'm sure they have better white papers about it, but that's our NFS. That's what serves our user home and work in our group, and are active in our archive storages. We also have a Scratch storage that's a GPFS, and that's I believe about 1.5 petabytes, but I'd have to double check that. That one has like a 30-day page off for any data on it. So I don't think it's Jimmy Dorf is asking what is the NFS server. I don't think VAST works as like strictly NFS server. It's kind of its own package solution, but it allows for an NFS export of the data. Yeah, VAST.
Yeah. So, and I think you just addressed my next question was going to be, what's your policy for how long people can leave it on Scratch? And I believe you said 30 days.
Yeah, we do a 30-day age off of the files, 30 days after they're written, or
okay,
last written sooner than they'll be aged off.
Okay. Can they touch the stuff?
That's that's been an ongoing issue. I don't know what we do at the moment. I believe we do creation date, but in the past we've done like last access date, and people would write scripts to go through and touch their entire directory and cause issues that way. So we had to.
That's been going on since I was a graduate student on your systems.
Yeah,
30 years ago. So
when I was much newer here, I had to go. I went through. Well, I had to go and track down some of these touch scripts that people were using and tell them we stopped.
Mhm.
Yeah.
Hey, so I had a question about these scripts that you're using, the sort of the analysis you're doing. Can you make those available to some of the people on this call that would be interested in them? And sort of a immediate follow-up is, if you did, would they find them useful, or are they specifically tuned toward your clusters?
I think they vary. I am, if anyone is interested, I'm more welcome to talk to them about stuff and maybe share some of the specifics around SK time I did. A lot of the code itself is very specific to the cluster and the data sources, so I'm not sure it'd be immediately helpful. But I'm more welcome to discuss with anyone like the general process of doing the forecast that I did.
Great. We had a question about the chargeback mechanism, and I think Amit is answering that currently in the chat, but the chargeback mechanism for storage sustainability.
Yeah, I would defer to whatever Amit has to say on that. I'm not the one who'd be issuing chargebacks to anybody, but
Okay.
looks like you said that we do.
Okay. And I think you don't have so you said you did an analysis of the distribution of, basically PI versus the total amount of storage that they were actually using versus the SLA. In terms of what did that distribution, is that a long tail, the big head, a small head? How would you characterize that distribution?
So you're saying like on a PI level, like how much are they paying for and how much are they using? So I don't have anything of that offhand. It's certainly something I have the data for available. Based on what I've looked at for the data, we have a few users that are very large quotas and very heavily utilized, and we have a lot of users who are very small quotas and very low utilized. We sell storage quotas in blocks of 5 2B bytes, and it would be uncommon to see someone who has the minimum size, but maybe somebody using a few hundred gigabytes worth of the actual storage.
Gotcha. I know I asked that because when we did an analysis, we had to move everybody off of Box, like I'm sure many of the people on this call did. And when we did an analysis of that, we had something like 19,000 accounts in Box, and of those, that were non-zero storage. So everybody got Box space, but a lot of them never used it at all. But we had about 19,000 individual accounts that were actively using Box, and we found out that of the total number of petabytes that we had, the first 50 users were about a third to 40% of that utilization. So it was kind of a very big head and an extremely long tail in terms of that distribution.
Yeah, I think it'd be similar for us. One thing that could make it a bit harder to discern is one of our largest storage allocations is for the College of Liberal Arts, like the entire college, and they kind of police it among their own users. So that kind of by nature is a bit different than like a singular PI who just wants their own storage. But yeah, there's definitely a lot more, like you said, like a big head, like a lot of, I guess you can call them power users in terms of storage.
Yeah, like the people that run the instruments and the people that generate a lot of model data.
And there are some users who are more interested in storing data than using data, and you'll see them have fairly large archive allocations, but maybe a relatively small active allocation.
Okay, and then and as I recall, the storage costs about a fourth of what it costs. The archive storage costs about a fourth of what it costs, I think, for the active storage.
I don't have the prices on me at the moment, but that sounds about right. It's a lower price point, but it's not actively mounted on the compute. It has a very specific way to get into it. I always use it to mount VAST on diskless nodes. As long as you have the network set up for it, it should be, you don't need like I guess it should be similar to any other kind of network storage appliance in terms of mounting on a node.
Okay.
We if you're doing something like a stateless node that you're running it out of RAM, as long as you can have like a mount point on it, it should work fine.
All right, I think you got all of the questions in the chat. Is there anybody else who just sort of like raise your hand, unmute your mic and ask a question to Derek?
Hi, Derek. I have one question. Oh, I'm Yu Cheng from Tufts University. I'm curious, like, does your center have any good suggestion that can reduce the total storage cost?
So the cost of like purchasing the storage, or just like how do we reduce our overall kind of
Yeah, or
so definitely maintaining good practices for storage like expired storage age off, or like if as users leave, you can clean up their directories and stuff like that is helpful for preventing the need to expand storage. I think that would certainly be a easier avenue than some others for in terms of keeping your if you can keep your overall storage uses down, that'll reduce the need for further purchases.
okay. Thank you. Also, how do you back up your data?
So I know we have snapshots of the storage system there. We also have some tape backups of different aspects. But I think we generally have just a snapshot available for ease of access, and then we have like a tape backup of the system.
Thank you.
Is there a way, and this is like a ongoing dilemma. So can I get an SLA that falls outside of my grant time? So if I get a grant for 3 years, but the requirements are that I have to store the data for 5 years or 10 years, can I buy an SLA, sort of in advance? Does that work?
Currently we do have like RSLAs that have a start and an end date, and you could get a start date that's in 2026 or 2027. And then as 27 approaches, that SLA becomes active.
Oh.
It should show up. I also have some work on, kind of separate from this, but I have some work on automating our SLAs to becoming system resources. So I scrape through the SLA data and kind of build a model of that. And then I use that to compare against the system and create storage allocations or compute allocations as needed.
And can you account for bursty demand, or do you do that through Scratch and then I move it over to my, you know what I'm saying, in terms of like a project will sort of burst beyond my quota. So would I just use Scratch to get around that, or would I?
So we don't have a means to we don't have like a soft limit on quotas. We have just a singular hard limit. So once you're at that quota, unless we increase that quota, there's no way going beyond it. If it's a very short-term need, you could get away with putting in Scratch because of the 30-day cleanup. I wouldn't necessarily recommend doing anything. In general, I don't think it's best practice to put something in Scratch that can't be regenerated or put there easily again. Don't keep like your thesis, your doctoral thesis in Scratch or something like that.
Yeah, good word to the wise. There's a question in the chat. How do you handle POSIX attributes, SMB, ACLs, when moving data originally from different sources?
Yeah, so our system underlying is POSIX. It's mostly running RHEL, and we use POSIX attributes for everything. We do support SMB amounts of the storage to certain users who need it. I find that the SMB mapping is sufficient for POSIX. Where it could get iffy is if someone is mounting the same storage both as SMB and say NFS and doing changes from both directions. So in that sense, we don't really allow that. Like you can mount our storage for SMB, but if you're accessing it on the system, it's just an FS mount. So moving data from different sources, I think it's not something we've had to handle too often, but if a user has a very specific need, we could work through some way to kind of remediate the data as it is ingested. Does that address the question?
Yeah, I think so. Let me, yeah, I think so. Do you have a way to, for a new user on the system to sort of estimate the type of usage that they're going to use? Are there sort of any guides to how would I set up? I have this type of problem. I'm a new faculty member in computational biology. Do you have any suggestions for what size SLA I should get? Or do you have a try and buy type thing?
Yeah, so we do provide like a trial SLA. It's usually about 1 month, but if we need to, we can be flexible with it. That'll give the user access to some of their desired compute resources, as well as usually just 5 terabyte 2 byte allocation of storage. Hopefully that period gives them a better idea of what their kind of footprint will be. It can be difficult to know offhand unless you know exactly, unless you have a really good idea of what kind of data they're handling, because the storage appliance does do data compression, and not all data compresses equally. So sometimes it's hard to really know what kind of usage will be until you have some time on the system to generate that data.
Gotcha. That seems fair. But do you see Victor's question about locking?
Those.
I don't know if I'd do it justice.
So I'm not sure if I can answer this specific one very well. I know that at least since we have it, we're exporting it as the NFS setting, at least on the node side, it would just kind of follow whatever locking protocol we have enabled there, but I don't know exactly what we have our current configurations for that.
Gotcha. Okay. Could you get back to Victor or somebody that
I can see if I can find something. I can try to follow up on that one.
Okay. All right. Great. So does anybody have any more questions? You know, again, feel free to raise your hand or just unmute and ask your question.
Yeah, Brian has a good point. There's an interface and an API in VAST. You can get a pretty good idea of if you think there's some abusive patterns going on, you can get a pretty good idea of who is accessing what and who's creating a lot of IO traffic at once.
CMU hammers fast from a Splunk instance, and it works just fine. So you got that piece of data.
Yeah, I just had some clarifying questions on the chargeback model, but I'm not sure if you even know how to answer them. But so, as I understand, so the SLAs are for a certain quota, right? So basically, PIs get charged for the whole quota, no matter how much they use.
Correct.
Okay, but do you also offer like I understand there's this trial SLA, but is there any sort of permanent free quota?
So users will have part of their, whenever you get an account, you'll have a home directory of, I want to say about 15 gigabytes, and they
Okay, so
work
that's
directory will
very
have
small.
120 or so for your work.
Mhm. And like, is there like a flat pricing model, or do you have some kind of, if you need more quota, you pay a different price than if you need less quota? I'm assuming probably that's too complicated, right?
I believe it's flat. Yeah.
Yeah. Okay. So none of this would really play into the forecasting.
Yeah, the forecasting doesn't have any bearing on the specific pricing of the storage.
Okay. Thank you.
Right.
Nathan is right. It's based on the logical usage. For the quota usage is based on the logical, not the raw usage on the actual storage. The compression is variable depending on the data, I believe.
Good point. All right. Before we people start dropping off the call, Brian would like to say something about next month's call and how we're going to proceed in there. I think we got something pretty interesting planned. So, Brian.
Yeah, and Matt, feel free to jump in if I don't catch all of the right things here, but the data facing track reached out and suggested a joint call, kind of starting off with kind of like how we did today, a shorter presentation kind of on the NSPM 33 publication from January, trying to stir up a good community conversation around the topics it's going to represent from a compliance and security overview. So probably the most important part of that is just to recognize that we will be holding that jointly in the data facing time slot, which is at the beginning of the month and not our normal third Thursday of the month. So that'll come out in the normal call announcement, and we'll try to do our best to keep people reminded of that unusual time slot, but it should be a very interesting topic.
Yeah, 100%. You nailed it, Brian. And for the folks here in this call, we can provide a sneak peek of what that session will entail. I've just pasted a link into our draft of the call document, which provides the abstract as well as our speaker that will provide a bit of an intro on what NSPM 33 is. And we're very grateful to have Carolyn Ellis, Director of Research, Cybersecurity and Compliance from Arizona State, joining us to provide a brief overview. And then we'll jump into the data facing side of the discussion, and we'll finish it off with the systems facing side, almost in response in terms of how can us systems facing folks support essentially the directives and the initiatives of our data facing folks, supporting our researchers in essentially complying with NSPM 33. Thanks, Brian.
All right.
And then last bit's November. We won't hold the meeting, which we haven't in the past, because we'll be very close to supercomputing for those who are attending, and watch for maybe some announcements about possible social events there at supercomputing. And then December will likely be another CARC end of year kind of event, and we'll return to normal kind of track calls January, at least for the systems facing track. So.
Okay. And I'd really like to thank Derek Haig for this month's presentation. A lot of thoughts. It's motivated a lot of thinking around supporting on-prem storage. Derek, if you don't mind, could you just put your email address, your contact information in the chat? Because I think there will be some people following up in terms of a more detailed methodology or some examples of your scripts. So that would be very helpful. So thanks, Derek, and thanks everybody that was able to attend this month. We really appreciate it. There's Derek's.
I put my Penn State email in there.
Yeah.
If anyone has any questions or input or critiques or anything, feel free to contact me.
Great. Okay. Well, thanks everybody. And again, reminder, it'll be earlier in the month next month because we're going to use the data facing slot. So please take a look for that. Get on the CARC Slack, and there'll be multiple announcements about it, both on the email list and on the CARC Slack. So to keep you reminded. So thanks everyone, and thanks to Derek.
Thanks.